let's talk about how you can get more out of the research that you read. Now, one of the big things that's been on my mind lately is how do I make my time more effective? When I try and learn something, how can I get more out of it? And a lot of it comes down to how we think and understanding what we're actually looking at. So when it comes to research, well, let me take a step back. There's two kinds of thinking. You can think linearly, or you can think in a systems approach. And we'll dive into that in a second, but first we'll describe each one. Now, linearly simply means things act one to one. So for example, if I have A, and A equals 1, and I add B, and B equals 1, I add them together, I get 2. Their relationship is 1 to 1. If I add more A or add more B, it's going to raise this number here. That's a linear approach. Think about it in terms of thinking about research. Affecting A here is going to affect B. And if this is linear, if this goes up by 1, then B will go up by 1. Again, the approach is linear, like a straight line. When you think about systems approaches, it's more about the interaction of these different aspects. So if we have A, B, and C, depending on how we order A, B, and C, depending on how these two act time dependently, will affect the outcome. In other words, this output is greater than the sum of the parts in isolation. Their output, A, B, and C, has a lot to do with how they are interacting or synergistically working with each other. How is A and B integrated into a system? Or A, B, and C in that case. So when we look at research, more times than not, research takes a linear approach. It wants to look at the relationship between one variable and another, right? We have our independent and dependent variable. And we're looking at whether or not, again, if we have A is 1, that's our, we're trying to affect B, our output. We're looking at if we affect A, what is the causal relationship on B, a direct linear line of connection. And then we use things like an R squared value to explain the amount of variance or the amount of impact an effect on A has on B. So that's what we look at in research. And that's really important because that helps us isolate specific variables like A. And then we get to look at some principles that influence A. For example, this might be a muscle, and you might look at what are the cellular aspects and principles that influence muscle growth. What are the type of loading properties that can be acted upon a muscle to increase muscular growth? And maybe what does nutrition or other factors that provide muscle protein synthesis affect muscular growth? So again, we isolate a variable so we can understand it. But again, muscular growth might have to interact with tendons, might have to interact with bones and all these other things when we're talking about the human body. Because again, the human body is what we call a system. Now, when it comes to understanding the human body, and there's a system right there, we have to understand, we'll draw a human body in this case. There's my human, yay. We have to understand we're not looking at necessarily linear relationships because we're actually looking at how all of these nodes in a network, A, B, C, and D, all interact to affect us. And so while research attempts to isolate these specific variables, it is our job to think about how they integrate as a whole into a system. And the reason why this is really important, I mentioned earlier there's two types of thinking. I said linear and systems. I meant to say nonlinear. This is a nonlinear approach. I apologize for that, by the way. If we look at a nonlinear approach, if we have A, B, C, and D influencing the body, there's our body right there, how we affect these or how we influence A, B, and C doesn't directly lead to a one-to-one influence on the human body. This guy here. Now that's really important because in isolation, we like to hope and pretend that they do, but in reality, integration is about the interpretation and theoretical aspects of how these variables relate to the human body. But isolation allows you to understand, like research, that independent node of a network. And the more we can understand how that node works in isolation, the more we can theorize about how it might interact, well, in integration within the system as a whole. So next time you read a research paper, don't just think about the A to B, right? The A to B linear relationship, but think about A to B, but what would happen if A interacts with C or A interacts with this other variable? And what outcomes those might manifest? Understanding what you're actually looking at can help you understand how you apply it. And that is so important because often we get lost in the academia of things. That is the publication of papers. It has to have a p-value, which is significance of the interaction in isolation. However, interaction isolation does not always mean interaction and integration in the whole complex system, because we need to take into consideration all the other things that research has isolated in the past. Let me give you a quick example. If we're just thinking about performance, like jump height, there are tons of variables, A, B, C, D, E, that have all shown to have some linear impact, again, significant explained variance on the impact on jump height. But we also have to remember A, B, C, D, and E are all interacting with each other. And the more that we understand that specific interaction, the more we can actually understand the causal influence they have on jump height. Because if we just took all the isolated variables and only trained and thought about those isolated variables, we would have so many things that would be quote unquote influencing jump height: maximal strength, maximal power, rate of force development, muscle tendon unit interaction, system organization from a coordination standpoint. Well, we wouldn't actually ever see an end game because we would be so stuck on thinking all these are isolated variables influencing it when really they're all dynamic interactions, which brings up the fact that we don't actually know the most important variable, but the more we understand each node, the more we can understand the probability of interaction and understanding based on that individual and their qualities that they showcase what might actually be impacting jump height. And you can then substitute jump height instead of jump height. You have injury, maybe you have whatever it might be, and the same idea takes place. It's that non-linear thinking that can help us understand what we see, these manifestations in, say, performance or injury, whatever it might be, but at the same time understand how we look and interpret linear bits of information like that of research to help us understand the dynamics of a complex system. So I hope that makes sense. It's a pretty cool topic, I know. Hopefully you nerd out about it like I do. I hope you enjoy it. Let me know what y'all think. I appreciate y'all as always. Thanks for listening.